today we're going to start learning about stars and constellations. Does anyone know anything about stars and constellations? They're all kind of, yeah?
Stars are in the sky at night.
Very cool, awesome. So just kind of start off our lesson today. We are going to look through a big telescope, and we're going to look at the fire alarm object on the wall and try to see what different details we can see about it. So if you guys will come over here, we're going to stand right over here and look through this. And afterwards, we're going to write observations. So if you hold the telescope and look, see the white thing on the wall? Okay, try to see what details you see about it. And remember, because you're going to write it on your observation after. Okay, go ahead and sit down. Okay, see what you see. Okay, awesome. So on these papers, you're going to write 2 observations that you saw from the telescope, okay? 2 details. Awesome. Okay, so each of you tell me one observation that you saw when looking through the telescope. You want to go ahead and go first?
The light was red.
Awesome job.
The lights were angled in different directions.
Oh, very nice observation. Okay, so what else are telescopes used for? Usually don't use them in a classroom to look at closer objects. We use them to look at distance. What would we look for? I know you mentioned it before, Carolyn. What was it? You remember? What you mentioned for no? Becca, do you know? Stars. Awesome. So use telescopes to look at stars, maybe the moon, different phases of the moon. But today we're going to learn just about stars and constellations, as I said earlier. So we're going to go through this short little presentation and kind of explain how stars form and the different constellations, and explain some different vocabulary that we need to go over. So a star is formed through 3 different stages. It starts out as a nebula, it goes into a protostar, and then it becomes a star. So it starts out as kind of like more of a gas, and then it goes through the protostar stage and becomes a star, and we're going to go through some more information as we go. So this is a picture of what a nebula looks like. It's a big, it's like lots of gas and dust, lots of space particles. There's another picture. So, to jump kind of ahead, when we have stars, they make constellations. And so, we are also learning about constellations today. And so, a constellation is a pattern of stars in the sky. Does anyone, have you ever seen a constellation? Do you kind of know at all, though? One that's really popular is the Big Dipper. I don't know, it kind of looks like a ladle is a good word for it. So, a constellation can be an animal, a person, or an object. So that's why the Big Dipper is a ladle. These constellations, they are named from stories and myths passed down from generations to generations. A lot of the constellations come from Greek mythology. And there are a total of 88 constellations. That's a lot. So we're only going to go over 4 today, so don't get scared about that. So a name to the few common constellations that we're going to go over is the Big Dipper, the Little Dipper, Cassiopeia, and Butes. And this is Cassiopeia. It looks like mountains, but it's upside down, so kind of like a valley in the mountains. And then the Little Dipper, which is a smaller ladle, and it's upside down. Sometimes people say that it's like a hat. And then the Big Dipper, which is on its side. And then this is Butes. Some people say it looks like a frog because it has like the arms and stuff, but this is the whole constellation. And then this is how the star dies. The hydrogen, it runs out of the star because that's how it's made through the nebula and the protostar, because when you have the protostar, it builds up lots of energy, and it comes together and forms a star, and as that energy slowly continues to turn and turn and turn as it's a star, and as it slows down, that's what breaks down the star. So when we think of a protostar, think about like it putting all the pieces together, kind of like Roadrunner when he goes really fast and he moves with us. Is kind of what it is like inside of the star. So then, as that like hydrogen that's inside the star starts to burn out, the outside it starts from the outside of the core. The star then begins to expand and it changes colors, and then the layers of the color they build up and then they start to fall away and they don't have as much color as they fall off. And then the star then collapses and it's called a white dwarf. So I know that's a lot of information, but just remember that when a star dies, all the energy that's inside the hydrogen, it burns out and it becomes a white dwarf. And that is the end of the presentation. Okay, so no, that was a lot of information, but we are going to go through a sequence map together of how a star, the correct sequence is how a star like it's formed through like protostar and like nebula and such. So we have these worksheets and we're going to go through it together. And we're going to start by looking at the first one. And so I think can you read me the first sentence that's on there?
This one?
Yes.
A protostar forms and increases in mass and continues to heat up and contract.
Okay. So go ahead and read. I'll read this one. The hydrogen is pulled into the center and begins to spin. This begins to heat up and contract. So kind of how we talked about the protostar, how it pulls everything in and starts to heat up. So the next one says, a star will start as a nebula, a cloud of gas and dust. The gas is hydrogen. So remember how the star was said, nebula, protostar, and star were the three different steps. So remember that. And the next one says, a nuclear fusion begins and the protostar stops contracting, which forms a star. So does anyone think they know what the first one is? What we do in the first box that we have? When you look through and it says, see, remember we start off as a nebula. Which one do you think?
A star will start as a nebula, a cloud of gas and dust. The gas is hydrogen.
Awesome. So should we put a star will start as a nebula and maybe just put a 1 down here so we know that it's in there because we don't have to write enough? Okay. So what about the second one? So if it starts off as a nebula, what do you think the next part is? It needs to become the protostar, right? So it would be the next step. So we see the first sentence talks about how a protostar forms and increases, and the next one talks about how the hydrogen is pulled in.
The hydrogen is pulled in.
Right. Good job. So go ahead and write number 2 by there. Now look at the other ones. So we have what do we think the last one would be? Because it has to end with a star, right?
Yeah. The fourth one would be the nuclear fusion begins.
Right. So that's probably the fourth one. So what would that leave us for the third box?
A protostar forms.
Awesome job. Okay, so let's go through those steps. So first, we start off with a star. A star will start off as a nebula, and then it's a cloud of gas and dust, and the gas is hydrogen. And then when it starts to become a protostar, it increases speed, it gets heated up, and it contracts, and it's like spinning, like we said, like a roadrunner. And then, as that hydrogen, it begins to spin, and that's when it becomes a star, because it has all that energy and stuff formed from it. Does that make more sense? We studied that? Okay. So, now that we are good with that, we're going to move on to working on constellations. So, I want you to think about what other constellations talked about in the present, and I'm going to pull it back up, and we'll show you both of them, and I want you to draw at least 2 constellations, and I have papers for you to draw those on. Draw 2 constellations that we talked about during the presentation. remembering of the constellations? Cassiopeia?
Yeah, that one.
It's a mountain.
Yeah,
Mm-hmm.
that.
Mm-hmm. You know how to spell it? So it'd be CASSEOPIA. Okay. So think on your own with one more and how cool this sounds. So here is 3 of them. And the Cassiopeia one is the one we put down here. I guess the eye. That's my bad. So there's that. Which one of those did you draw?
The Big Dipper.
Mm-hmm. Do that one. So, when we do our Cassiopeia, where do you think, or the Big Dipper, where do you think the stars are placed at? Maybe looking at here can help you. Is it at all the points, or is like in between the lines? What does it look like on the map?
Between the lines.
In between the lines? Well, I think that there's some stars in between the lines. Like you see at the points where there's more stars. So that's where the stars are. Does that make kind of a little bit more sense? So maybe on your sheets where you see that there's a point, draw like a big circle so that you're like kind of like, or draw a star, and where you're matching up the points. Awesome job. That looks really good. Okay, so we're going to talk really fast about how a star is formed again. What we talked about in our sequence now. So, do you know the first step in how a star is formed at all? Do you remember? Maybe pull up your sequence map that we worked on. What's the first one? How is that formed?
The nebula.
The nebula. It starts out as a nebula, and then it forms. And then what does it do? What does the nebula do, Becca? Do you remember?
There's hydrogen and it begins to spin.
Right, so it begins to spin, it gets really heated, and it contracts. And what is the second form of how a star forms, Marilyn? I think it's
Protostar.
the protostar. Awesome. So that second place is the protostar, and that's really where it's moving, it's contracting, it's getting all heated up. And then the fourth one is, well, the fourth part is, what would be the last one? Do you guys know? It's the easiest one of them all.
It's a star.
Yeah, it's a star. So that's how you know that the different stars are formed. And you will need to remember that as we do your homework this weekend. It's a cause and effect little chart thing. This is your homework. You will need to take these and put them into the boxes. You'll need to cut them out and paste them. And they will all line up. So whatever the cause is, so if the hydrogen is the fuel for our stars, so if that's a cause, you need to find the effect for that. Does that kind of make sense? Okay. You'll take these with your other papers you can take home.